go into a little bit more depth about classes and their methods, just to make sure we're really understanding how this whole object-oriented paradigm is working to a slightly deeper level. I've created a blank empty template class called hero that has an empty constructor, public hero. And in it, maybe I want to have the message, your hero has been born. However, I also want to be able to add in some information right off the bat about my hero, which is maybe their name. I can actually require parameters or information from the user or from the coder in my class constructor as well, just like in a method. And in here I can say string, and maybe I'm going to say it's the name that I want to have accepted here. So now I need to assign the name to a variable, which is where the top part of our class is concerned, because we have to think about something when methods and constructors appear called scope. Scope basically refers to where things exist and where they don't. For example, if I make a string called hero name here, and I assign it the name that comes in, now really quick here, name is the variable coming into the constructor, hero name is the variable inside of the constructor that I'm assigning the name that comes in to. All right, let's make another method here. Public string get hero name. What this is going to do, the intent of this is to actually let anyone who asks this class know what the current name of my hero is. So I'm going to return my hero name, no problem. Except there is a problem. My hero name, if I click on this and mouse over, we cannot find this symbol. Technically, the hero name doesn't exist in this scope. What's the problem? Because I initialize the name inside of my constructor, it only exists inside of it, not outside of it. The way that this works is think about moving to the right. Things exist for everything within their indentation as well as anything indented to the right. So if I was to have, I don't know, an if statement, if my hero name equals Raoul, then I could hero name equals Mr. Raoul. Maybe I want to just fix it up. If the hero name is Raoul, make it actually the full Mr. Raoul name. Hero name exists deeper in. It's accessible here because the scope, it's created outside. The deeper I go, it's still accessible. But if I head outside of this context, that hero name no longer exists technically. The scope is limited, meaning that I actually have to initialize this hero name outside at this level up here. Usually at the top of our class, we call our class variables, which are the variables that we want to be accessible throughout the whole class. And now look, hero name is happy. I don't need to initialize it here anymore. It's happy because it's initialized where everything can see it, and I can assign its value in the constructor and then refer to it later on. Now, you might have noticed that I kept the hero name initialized again here. This might cause some issues because if we initialize it twice, it's getting reinitialized inside of my constructor, meaning that this hero name and this hero name are now technically different ones. So this actually will think it's returning something, but it's going to return a null or empty value because this is actually never assigned to because it's a different hero name. So I don't want to actually define the type multiple times. That would be an issue here. Okay, so now we've been able to pass in some information and assign it as a class variable, and I created a bit of a method here that reports the name that I chose. Let's test this and make sure that it's working. So I'm going to create a hero by actually building this here, and I don't think I actually saved this. Let's go press Control S to save, and let's see if this pops up here. Popping up, and it's erroring because our hero requires a string for its name. So I actually have to send it a name here. Let's call this hero Arya, the name of my new daughter. And now it's happy because it requires a name of the hero that's being created. Now my program, well, if I run it, what is it that I see so far? I see your hero has been born, but that's it because I only have that as being some of the functionality that's being performed. What if I wanted to next actually know what my hero's name is? Hero, and I have this method already built to get the hero name. Oh, sorry, that's the get hero name is the method that I'm looking for. And because it returns the value, I actually have to print this out with a sout call. Let's get the hero name and print it out to the world. So the hero is Arya, and it's going to print out your hero's been born. Arya is the name. So I've accessed this name. Wonderful. But here's where things get a little bit more, well, wonderful, but also a bit more complicated. What if I have another hero? This hero, I have to give it a different name. Maybe I'll just call it Hero 2 for now. It's a new hero, and I name it Locke, my first child's name. And now I print out my hero dot, let me type it in, get hero name. Notice, really quick, that I can't name this the same thing as above, which is why I named it Hero 2. But what if I reference Hero again? Let's see what happens. Both of the printouts are Arya, because in both cases I'm accessing the object that was initialized with Arya as the name. I'm not accessing the object that with Locke as a name down below here. To do so, I'd actually have to access the hero2 object. And once I do so, my hero name is Locke. Wonderful. So here is something at the very core of how object-oriented coding languages are designed to work. I've made a single blueprint called hero. It's very simple. I add a name to it, it remembers that name, and I can access that name. That's all I can do so far. With that one blueprint, however, I can create two different heroes. And if I really wanted to get crazy, I could add a hero 3, a new hero called Yolanda, the name of my wife. And I could print out that name, hero 3, get hero name. When I print this out, I now have a third object of type hero named Yolanda. With one blueprint, I was able to make 3 different characters. These are very simple ones, but we can imagine with time, what if I built in a whole bunch of other interesting methods? Maybe something like attack. Maybe I have an attack ability. Maybe I have a public void cast spell for something, and maybe I accepted like a spell name to process which spell I wanted to cast, and maybe I had another one, int get health, that returns the health value. I don't have a health value yet, so what if I create one up here? I'll just make this an int health. So now I can maybe set a health. Where would I do so? Well, in the constructor, I could just say health equals 10. Maybe I'll give all my heroes 10 health to start with. Now I can return health, and suddenly I'm building a more complex entity through this blueprint. Now that I've added all these methods, each one of these characters, hero 1 is able to access all of the new things. Hero 2 is able to access all the things, and same with hero 3. Since they're built on the same blueprint, they all have access to the same common set of attributes and methods, allowing us to build a really complex, customizable, singular blueprint or class, and then implement it as many times as I want. It's a little bit like if I wanted to plant some trees. I could make a tree class one time that describes a tree, and then I could use a loop to create a million of them. And technically, I have now created a million trees, and I'm super, environmentally aware in my game. So classes are the blueprints, objects are the instantiated version of them, and I can have as many instances of the classes as I want. I just then have to remember which instance contains which information, because each of them are going to have their own unique subset of information. All of the data that's inside of them will be unique to each one of those things. There is one way around it that I'll show you really quickly here. Let's say really quick, I'm going to add in my HP for my health. I'm going to set my health to HP. I just want to see really clearly that each of these heroes is going to have a different health value. I'm going to give Arya 100. I'm going to give Locke 50. I'm going to give my wife 10. Don't tell her, okay? She's really squishy. She's a glass cannon. And so they each have different health amounts. So I could also now run, well, maybe instead of getting the name, let's get the health value printed out. So let's replace each of these with the health value and just double check that this is working really quick here. Each of them has their own different amounts of health. Hopefully that's really clear and obvious. But what if I were to do something like this? Static, a term that we have seen before in coding. When I run this, so far all the health. Oh, I know I did something in the wrong order here. Let me go back and quickly fix something so we can see this really clearly. I want to actually print out, go back to the new class, each of these printouts at the end after everything has been defined. So let's print out each of these things at the end here. Okay, so these different health values, just to prove it here, they're still all separate because I've created them separately. 150 and 10. But if I make the value static, now we'll see the values being a bit different. 10 for everything. What static does is it forces every single instance of hero to share the same information, which means when I create Arya, health is 100. When I create Locke, health is now set to 50, and because it's static, it's shared between all of the instances, meaning that Arya's is also set to 50. And then when I set Yolanda's to 10, all of them are set to 10. Just to really prove this, let me shift the order a little bit, and let's allow Locke's to be last. And when I run this, because it's last and static, all of them are 50. So if I want there to be shared attributes between all heroes, I can make them static. And that attribute will then be shared by everything. So there is a way around that instance of information. Last thing I want to show you in this tutorial is that traditionally in Java, we like to have really tight control of our access. And we like to manage our access to variables always through methods like this getHealth method. I actually don't want to be able to do things like this, where my hero, if I press hero dot, I actually can see the health and the hero name variables, meaning that I could technically go right in and set the health to 0 right here. We don't like having direct access to variables like this in Java. It's not the way that it's meant to kind of be written. So what I need to do then in hero is make my variables private, meaning they can no longer be seen anywhere outside. So when I type in hero and dot, those variables are now gone. And if I want to be able to, for example, change the health, instead of accessing it directly, well, you know what I can do? I can make a method, public void set health. And I'll take in the new health value, and I'll set my health to be equal to the new health value. So I've built a method that allows me to indirectly access and set that health value. So if I go back over to my new class, I can go hero dot set health and then say now, I want you to have 0 health. So technically that means that you've died. But that's some functionality I might want in this experience. And this is the way that I want to see you managing access to all of your different variables inside of your classes.